Good afternoon. Today I'm going to show you my project, which is on smart refrigerator. Our team members are Dylan, Junhwan, and me, James. Here's my content page. This is our project story. We want to create something to help the business owner, especially in supermarket, to save manpower operating costs, in the meanwhile allowing investors to invest more on new technology, boosting innovation and their competitiveness. This is our project objective statement. In this project itself, it will include 3 input, 2 output, as well as 1 actuator. So we want to create something that can save manpower, cheap in cost, and easily maintain and install. Most importantly, the material we use is environmental friendly. So here is our project concept. Here will be a list of general objectives of the smart refrigerator. Firstly, will be TOF sensor to detect items within the refrigerator, followed by the light sensor to control the LED light, then followed by environment sensor to detect temperature. Then is LED to give user better vision. Then the buzzer to remind user. Lastly is the model acts as a refueler. Here is the timeline for our project development. We are not just doing this module alone, but doing other modules simultaneously. So we have to manage our time very wisely. Next, I'm going to hand my time to Junhwan.
Okay, so we are going to talk about the components we use for this slide, as we use a TOF sensor, a light sensor, environmental sensor, 2 and 5 stacks, and obviously a pH hub. So next slide. So the first usage of the light sensor and the M5 stack is that the light sensor acts as a sensor that turns on the light of the M5 stacks when the fridge door is open. And the M5 stack will also display an on-off to show whether the light is turned on and off. So when the door is actually closed, the M5 stack light that is inside the fridge actually will also turn on. Next slide, please. So for the second usage, it will be the TOF sensor, the environment sensor, and of course a M5 stack unit. Environmental sensor will sense the temperature of the fridge, whether it is at a suitable range. TOF sensor works as a distance measure to see if the distance in the fridge are refilled after being taken. M5 stack works as a display to see the distance range of the item and TOF sensor, as well as a recording of temperature and a buzzer. Next slide. So our usage 3 is, of course, the PA hub and the motor sensor. So for PA hub, it acts as a combination of environment sensors and TOF sensors, so they can be connected together. Because the M5 stack actually has a limited port for us to plug in. So for our last sensor, it will be actually a servo motor acting as a refilling of product. After TOF sensor sense that an item has been taken and the range of the distance of the items is not in a suitable range, the buzzer, which is the M5 stack, will alert and the motor will start moving the items from the bag to refill it. Next slide, please. So this is the overall action sequence of our project. So the light sensor detects door opening and closing, a trigger LED from M5 stack to allow user to have better vision. M5 stack also display an on-off icon to show light status. Environment sensor monitors fridge to ensure temperature is within a suitable range. A TOF sensor to monitor distance measure to see if the items in the fridge needed to be refilled, as well as M5 stacks, our main product of the project. It works as a display to see the distance range of the item and TOF sensor recording temperature. and a buzzer to remind the user that the item is refilling. So I have done with my slides. I'm gonna pass this to Dylan.
Now, I will be talking about the flowchart for our prototype. For the main M5 stack, we have the TOF and the ENV3 sensors. So firstly, it will display the startup menu of the M5 stack and display the both sensors statues. Starting with the TOF statues, it will check that the distance value from the TOF sensor if its distance is more than or equals to 300 mm. If it is true, the M5 stack will beep, the red LED lights up, and will prompt the servo motor to pull out the item from the fridge. It will then display the distance and light up the green LED once the distance falls below 300 mm and repeat the loop. For the ENV3, it will check the temperature from the ENV3 sensor. If its temperature is more than or equals to 35 degrees Celsius, the M5 stack will also beep and light up the blue LED. Once it displays the temperature, the green LED lights up once the temperature falls below 35 degrees. Next. For the secondary M5 stack, we have the light sensor. First, it will display the light statues and check the luminosity value from the light sensor. If it detects a value below 300, the M5 stack lights will be turned off, while if it's more than or equals to 300, the M5 stack will light on. And then it will display the luminosity with corresponding images and LED, and therefore repeat the loop again. Next. This is our finalized circuit photo of our prototype, as you can see. Next. So, here are some of the challenges that we faced during the project development. Our original idea was that we using a laptop to control two M5 stacks simultaneously, only finding out that a laptop could only connect one M5 stack at a time when we are assembling our prototype. In the end, we had to redesign our prototype in order to implement the changes. Secondly, we have time management. Since we only started our project 2 weeks before the deadline, we had to put in extra effort and while handling other assignments for other modules. And lastly, we had a lack of manpower. We only had 3 members to do this project, which one unfortunately went missing. So we only had 3 members to work on the entire project. Next. This is our YouTube video link for the presentation later on. Next. Thank you for your kind attention, and we will now do a short demo on our prototype.
Okay, so let us introduce to you to our smart refrigerator. So this is the light sensor that is controlling the light effects of our fridge. This is the TOF, which is under the fridge. It detects the distance of the items inside. So for this smart fridge, we are using 2 M5 stacks. One which is to control the light, and one outside which is to control the TOF, the environmental sensor, and yeah. And we got one environmental sensor which is inside the fridge as well to control the temperature of the fridge. Okay, so what our smart fridge does is when the door is closed, the light sensor inside of the fridge will be off. When it is open, it will light up. Then next we have the TOF sensor, which when it detects an object that is not there, the motor will start prompting. So let's simulate this. Yeah, this is just a simulation of how our motor will bring out the item. Yeah.